Let's see. Okay, we're live. Hi, Sedef. This is the Antrea live show, everybody. And DWAYNE is here. And Sedef. my two friends. DWAYNE, tell me about yourself. And then Sedef, you next.
Well, I'm a field engineer here at VMware. And
Cool.
I was introduced to CAPA when I joined VMware earlier February. So I thought it was neat that you can do what do you say, clustering clusters, guest clusters, management clusters, and all the silly little stuff that we do. So I thought it was interesting, and I like the opinions that surround the project. So, and I'm an AWS guy by trade, right? So I have a lot of certs in AWS. So that kind of matches, and I was interested in learning Go. So
okay.
That kind of all mixed together.
Okay, that's cool. So you're a field engineer, and then Sedef is my friend. We joined Clint Kinston's team. We're also VMware early on, and we were doing networking stuff like early on in the Antrea days. So Sedef, what's up? You want to say hi to everybody and let them know?
Yeah. Hi everyone. I am Sedef. I've been with VMware for the last 2 years. As Jay mentioned, we started working together on CNIs for a while. Fun times. And then I moved to Cluster-API, which is a Kubernetes Cluster lifecycle sub-project. We will dig deep into it in a few. So that's me.
Cool. Okay. So let's get. We got a lot of people. Let's see. So we got a lot of people, I think, showing up today. It seems like so. Okay. Cool. How do we start? Okay. So folks in the stream, please say hi so we can know where you're here from. Now let me do the news and then we're going to get started. And Sedef is going to tell us everything about CAPA networking and DWAYNE about the whole topology, how it's set up. And so they're the experts. I don't have much news, but here's what I've got. So they've got 123 dual stack is GA now. Okay. So, I don't know. I haven't been tracking this thing, so I don't know. I've never tested dual stack before, other than like one time I tried to see if I could get it to work and I broke networking on my laptop. So, but evidently you can, it's GA. So that's like an API change. It's been around for a while and it's been working for a while. And then the other thing is, this is just something that we played around with this weekend and we found it's an issue in KPNG. We've talked about it before on this show. It's the next generation kube proxy. And we found out that we were exploring endpoints and we found that the endpoints API in KPNG, we need to make a few small improvements. So I thought this was a little interesting bit of trivia for people who want to learn more about how K8 services work. So it turns out that, every endpoint has inside of it these conditions, right? And so, you can have an endpoint that's ready. Most of you all probably know this, right? You have an endpoint that's ready, it's not ready. And depending on whether it's ready or not, a service will forward traffic to it and all that. And so what we found, which was interesting, is in the current Kaping, we haven't modeled that data yet. And so Neha found this, and she was working with Anusha Hedge, who's another CAPI person. Do you know Anusha, Sedef? Maybe you know her. She works on BYOH and CAPI. She did like a TGIK episode on that the other day. But anyways, so yeah. Anusha and Neha were sort of pairing on getting endpoint readiness into KPNG, the next gen kube proxy, so that we can sort of pass some of these end-to-end tests that we don't yet pass, like the endpoints for unready pods test, which is kind of tests an interesting corner case. In terms of you actually make endpoints for unready pods, and you actually set up routing to them. But even though you set up routing to them, if I remember it correctly, you set up routing to the endpoints, but you don't necessarily like load balance to those endpoints from the proxy. So like there's other stuff, there's other weird corner cases like this that we haven't modeled yet. So we're working on that in KPNG. What else? Yeah, that's kind of all the news I got. I just kind of made it up last minute because that's all I know from this week. So, Sedef, go take it away. Show us everything. What's up, Grayson? Hi, Scott. Oh, cool. Lubron's here. And Lubron is here and he's working with Sedef and other folks. Thanks, Zach. Hi, Vivek. Me and Vivek, I got to hang out with Vivek today. He's doing some cool stuff with K3s still. Yeah. So Sedef, go ahead, share your screen and get us started. And DWAYNE, just interrupt anytime. We're not in Zoom, so you don't have to you don't have to use the raise hand feature here. Okay. All right.
Cool. You can see my screen, right?
Yeah. If you've got links, post them in the HackMD if you've got links you want to share with people.
Okay, sounds good. Yeah, so briefly, I want to give an overview about what we do in Cluster API projects to start with. So it's basically what it does is managing lifecycle management on Kubernetes clusters using Kubernetes clusters. And it does it by extending Kubernetes APIs and managing Kubernetes infrastructure by using Kubernetes constructs for like scaling up and down, deleting, creating, and it enables basically users to bring up Kubernetes clusters in almost all major cloud providers. And today, in particular, we are going to focus on AWS. The project that does the infrastructure provisioning is called Cluster API Provider AWS. Let me show you our book for it.
Are you doing the EKS one or the regular AWS one? And what's the difference? Because I look in the directory in the code sometimes and I see both.
Yeah, so EKS support actually GA'd very recently. So we support both EKS and regular self-managed Kubernetes clusters.
Cool.
So yeah, so this is the book, and the Cluster API has another book. Basically, Cluster API is a construct that is contract that is implemented by provider repositories. Let me show you the repository as well. This is the Cluster API Provider AWS repository. And Cluster API contract basically deals with the common settings like keeping high level of information, not cloud specific information, like kubeadm config, number of worker nodes you wanna spin up, number of control plane nodes, Kubernetes versions. This kind of information is kept in Cluster API objects, and the provider side of the things is more like cloud specific that I'm gonna show you in a bit. Let me quickly draw and try to move. Yeah, so I recently came up with this cool tool that I'm able to draw.
Sedef was showing me Google Jam today, but we can't use. I couldn't figure out how to use it because I think you have to pay for it if you have so you must be using your personal email for this, huh?
Yeah. So
I want to say hi to two people, Sedef. Can I do that?
Sure.
I want to say hi to Scott and also Claudio, and it's 11 o'clock at night for Claudio, and he made it. He made it to the show. How do you feel about that, DWAYNE? Soldier. Okay. And then Scott's here, and he's a big supporter of us here. And Friedrich is here. Friedrich, the creator of SigWindows DevTools, and now one of our favorite Kaping people. So yeah, cool. Thanks everybody for coming. All right. Here we go. Beautiful diagram, Sedef. You're using your iPad?
Okay. So this is our management cluster. This is basically a Kubernetes cluster with additional controllers, Cluster API controller and CAPA. CAPA is short for Cluster API Provider AWS. And using this Kubernetes cluster, we can bring up workload clusters from actually any AWS or Azure or nowadays Google Cloud providers. And this management cluster can live in your local laptop or can be hosted in AWS. Doesn't matter. So maybe I shouldn't draw. Terrible.
I like your
Sorry.
drawing. Keep drawing. It's good. Nobody ever draws
Okay.
on this show.
Okay, yeah. So yeah, go ahead.
Yeah, you're on a roll. Keep going. Don't stop.
Okay. Cool.
Everybody
Yeah.
likes your drawing, Sedef.
Yeah, I will try to dive deep into AWS resources we need to create for a Kubernetes cluster and what networking resources we are using for host node networking. So let me do another nice drawing about the our default network topology that we support in CAPA. Oh, it didn't move to the next page. Oh, I should do it manually. Okay, cool. Yeah, say we are in a region with 2 availability zones.
Okay, so that box is like the cloud.
This is region.
Okay.
This is region.
Like I feel like I'm
and
contributing to this diagram. Yeah.
this is public subnet. This is private.
What do you draw with, DWAYNE? How does DWAYNE draw? You just
I draw with a pencil.
how do you share it with people?
Oh,
What are you gonna do when you're gonna come to a show with us someday? What are you gonna do?
I'm gonna do a old school PowerPoint, or maybe everybody's all high off of a Miro board, so I might do something in Miro real quick.
Miro,
whatever. Yeah.
I used to hate Miro, and then Lori got me using Miro.
Oh, good.
If you want to see some really good Miro diagrams, you should totally ask Lori.
Oh, okay. Yes, I
Lori,
like.
She works with us. Yeah.
Yeah, I like Miro. It's pretty cool.
Okay, I by mistake placed our net gateway to private subnet. Anyway, so we create an internet gateway for internet connectivity to our not the region, of course. This is VPC. I'm sorry, I'm confused. So this is our VPC. Okay, and all the by default we bring up all our worker and control plane nodes in the private subnet.
She didn't see.
Yeah, I saw it. Don't worry about it. Keep going. Keep going.
Keep going to that.
Keep going. Oh, gosh. Oh no.
Okay.
Now you have to tell me.
I just made a joke about how we could get Lori to redraw your diagram later. Okay.
Okay.
16. Okay, cool. So then we have we have a public and a private. Okay. And they're both in different AZs.
Yeah, and we have net gateway in public subnets. And then our load balancer for API server is also in the public. Yeah.
Okay.
A single one. Actually, I shouldn't. Yeah.
Oh, I see what you're doing. Yeah, you can fit. Okay.
I shouldn't put load balancer nodes. Actually, we create a single load balancer for API server, but load balancer nodes spans across availability zones that is attached to the load balancer.
Okay.
So, although I am drawing right now 2 load balancer, actually this is a single load balancer.
Okay. Single load balancer. Okay.
Yeah.
Okay.
This is
so the load balancers are zone specific, not are there regional load balancers in AWS?
No, there's a Route 53 if you want that type of functionality.
Okay. So you can't do a regional IP. You can do a availability zone specific IP, but if you're willing to do a DNS, if you're willing to do a layer 7 thing, you can do it. That's how you would do that. Okay.
Okay. Also, to be able to reach our nodes in the private subnet, we have a jump. We can have a jump host called Bastion, or I am personally using AWS Session Manager. And yeah, that's pretty much it.
That Bastion is like spanning. What it's like in the AZ1, but it's also in the region. Is it supposed to be in the? Is it in one of those availability zones, or is it outside of both of them?
Actually, it is in one of the availability zones.
So how does
One
it?
of the subnets.
So how does it access the other availability zone? It doesn't.
It does. So in a VPC, they can communicate with private IPs.
Okay, so there's a VPC spanning. I see. Oh, I forgot
Yeah.
that the VPC was on the outside. Yeah, you're right. Okay, cool.
Yeah, I initially wrote region, so you're
I get
right.
confused thinking about regions and VPCs because I've been working on vSphere for like 2 years and I forgot how the cloud works. Okay.
Yeah, so let me show you some YAML files we used to.
Lori says she only draws NFTs, and then
I gave I sent you a picture. I don't know if you can probably if you want you can use that. It wasn't complete, Sedef, but the picture I sent you yesterday might be a little bit more helpful, or it will add to what you showed.
Yeah. So yeah, I need to. Yeah.
okay, cool. So now this is the cluster AWS YAML. Okay, I'll let you pull that up, and then while you pull that up,
Sure.
we can tell a joke because Claudio gave us the joke to tell. So Claudio says, if you have two, so Claudio makes jokes. He's a major helper for us in SigWindows. He does all the image management and all the image submission and all that. And we, yeah. So he says if you have two 8-bit numbers and you generate an overflow bit, and it generates an overflow bit from there, you could say that the resulting sum is a bit too much.
Wonk, wonk, wonk.
What do you like that joke, Sedef?
I like it.
Yeah.
It's cute.
All right. He's
Okay,
got more.
I'm
Okay.
resharing.
Can we get some SigWindows NFTs?
You need to accept my screen
Yeah, here we go.
sharing.
Okay, this is oh, beautiful. Okay, cool.
Yeah, this is by DWAYNE. Do you wanna talk about it, DWAYNE?
Yeah, I mean, more, it gives more color to what you were mentioning earlier. Basically, you have, a line of items on the left-hand side. It shows kind of like your authority, your authorization. We all know that you do nothing in AWS without STS. And that's where you get your keys and your verification and validation from.
What's STS? I don't know what that is.
Oh, security token.
Okay.
Security token service.
Yeah.
So you can do nothing in AWS without that. So that's how Cluster API provisions this, is that you take a token off of a user or profile that you created in AWS, and you use that account to provision, to tell CAPA to provision these resources onto that account. So that's pretty much how this works. And there's your internet gateway, and there's all these fun little toys and tools and stuff that you see. I think this one is the high availability model. So by default, CAPA deploys in two ways. The first one is development, and the second one is high availability. So high availability means it creates a quorum for etcd for you automatically, which means it deploys 3 EC2 instances with a master node, or 3 master nodes, 3 master nodes with 3 EC2, 3 etcd services, all in a quorum talking to each other. And then out of that deployment, you can start creating guest clusters, which you see there far on the right, because you can create as many guest clusters as you want. So I think the nomenclature here, the model here is to say, hey, this is a hyper visualization of a high availability deployment of CAPA, and I think downstream from CAPA, and a better articulation would be Tanzu or TKG. And this kind of happens on VMware the same way, except I'm not expressing supervisor clusters at all to manage that deployment or anything like that. I think that makes so some of these pictures here make a little bit more sense. The things that I was unclear about was the Elastic Network Interface. And so if you can probably clear me up on the Elastic Network Interface on how many of those are deployed under the development deployment plan versus the high availability deployment plan.
Yeah,
So
actually, I'm gonna show them in the AWS console what we are creating.
Awesome.
In a minute.
Okay, good.
Cool. So yeah, let's see some YAMLs, what we are describing in for example, 1 second, AWS cluster, specifying in AWS cluster object. So this is our AWS cluster object, where we enabled the Bastion node, and we want our cluster to come up in Europe West region. And then we use this SSH key so that when we SSH into Bastion, we can use the correct credentials, because this SSH credentials are copied to the instances during a boot up with Cloud Init. And I only specified how many availability zones I want to use in this AWS clusters. That's it. And I actually went ahead and created the cluster.
You named it after us.
Yeah.
That's the nicest thing anybody's ever done for me.
So yeah. So we have a CLI called Cluster AWS ADM.
If I have to interrupt you again, Gok Gruler is here from California, and he works at Twitter.
Oh, awesome.
Hi, Gok.
I bet we know where. Okay, I bet we know how we got him. Okay, cool.
Yeah. Okay. Yeah. So these are the resources created by CAPA. We will go and see what they do in the AWS console, and let's see the AWS cluster object after it is created, like actual status right now.
Well, okay. So this very special cluster, probably the first cluster ever created that was named after this show. So
cool. Yeah. So right now we are allowing. So this is the security group. So by default, we allow all traffic into the Bastion, but this can be customized. And then we have a load balancer for our API servers created and serving under this port. And our load balancer is internet facing. And in CAPA, we support multi-tenancy also. So you don't need to actually use the credentials you started your CAPA controllers with. For each workload cluster, for example, different teams can have their own credentials, and using the same management cluster with different credentials, they can spin up their controllers in their own with their own IAMs.
That's a new thing, right? That was like a new feature. It took some work to add that, right? Because we used to do something weird.
Yeah. So
use credentials or something, right? Yeah.
So previously, people were using things like Kiam for supporting multi-tenancy, and for each workload, each identity, they were spinning up new cluster API controllers.
Vivek had a question. He says, do we support So EKS supports this concept of a placement group, right? So Vivek had a question of whether CAPA supports that yet.
I'm not sure about placements groups. I've never checked them. So yeah, the answer is no. We don't support them because
Because we
I
don't,
don't
yeah.
know.
Because if so, you would
I
know
mean,
about it.
maybe we can look into it. So if Kappa is deploying high availability, that would obviously go against a placement group, right? Because we want a placement group to eliminate jitter on the network, right?
Mhm.
So you may have workloads that need to be close to each other in the same AZ for whatever reason. And Amazon kind of like guarantees certain levels of telemetry and the transfer of network traffic when you put them in the same placement group. So I don't know if the CAPA API enables that or not.
Vivek is telco guy. That's why he asks questions like that. Just wants everything to be fast. So,
Well, telco voice over. Yeah, okay. If you're doing something on that.
yeah. So okay, that makes sense. So that with placement group, is it like same rack?
Think of it. That's a good analogy. Think of it like that. Same rack.
Okay. Cool. Okay, Sedef, keep going.
Okay, I see some placement groups.
Oh, she looked it up. There you go.
Maybe that's in the EKS part.
I'm learning.
She had to,
That's good. That's what we do on this show.
that's right. You look it up.
Cool. Yeah, I will look it up
We
later,
grab.
yeah. So cool. Let's go back, and we see that. So in this network spec, users are able to add some additional rules for their particular CNI, for which ingress egress ports they wanna allow in which CIDRs, for example. By default, we allow some like BGP, IP and IP ports, but I mean more can be added based on whatever CNI, which ports CNIs want to be open.
Okay.
Yeah.
Yes. I remember when we added the CNI Ingress Rules and we had to add a new one. So here's some history. We used to we hard coded Calico into the CNI Ingress Rules originally, and then we later had to make a data model placeholder for it so that we could have different CNI Ingress Rules for other things like Antrea. Right. And so I remember when Gab Sachi did that, I think he added that CNI Ingress Rules stuff to the AWS so that you could open up, because you can have all these security groups when you start, and like blocks, different CNIs use different ports to communicate UDP and stuff. So yeah, cool.
Right. Yeah. So we have plans to even extend it further to other security groups too, and also allow users to like add some custom egress rules. Now we only have ingress rule support, and egress is open to anyone. So we are gonna improve our security by adding those features. Cool. Right now we are seeing our VPC console. Right now, let me first show you what instances came up for my cluster. I created an HA cluster. So I have 3 control plane nodes. I didn't spin up any worker nodes. I have a single bastion node that is sitting on the public subnet. And for this kind of cluster, let's see the VPC. Okay, we have a VPC, and we can modify this VPC CIDR in the cluster object itself. So no, sorry, in the AWS cluster object. Okay, we didn't specify anything for the VPC, but if we go to
Okay.
network spec. Yeah.
Cool.
Okay, yeah, we can like just set a cider block for our VPC, and we even support adding secondary cider block, because I think AWS CNI allows you to use a secondary cider block.
So what's that secondary cider block for?
It's just adding like another cider here. We can.
Why would you want two cider blocks? So you'd have two cider blocks for your nodes, so they go into this block or another?
No.
Yeah.
Is it what? Is it IP4 versus IP6?
No.
No. Go back. I'm just trying to
See, you can add IP4 secondary cider blocks to a VPC.
Interesting.
Cool.
Yeah, and EKS has support for this. That's why we also have support.
So are those no? So help me understand something. I think are those cider blocks the separation between services, pod services, and services in the cluster? Service.
No, actually they are different. So these are for nodes.
Interesting.
For pods and server ciders, we are setting those in the cluster object, and
network.
they are
Okay.
Kubernetes specific. Yeah.
Interesting. Okay.
Cool.
Okay, and let me show you the route table in the VPC is we don't change anything. It's basically everything in its cider local traffic. And then when we come to the subnets, as I mentioned, we create one private, one public subnet for each availability zone. So you see, we have two public and two private subnets because we have two availability zones. Let's see how their route tables look like.
Oh, that was in your picture earlier, right?
Yeah.
Yeah.
The public subnet has a route to internet gateway for any traffic other than its own local traffic. And the private, which one is private? Yeah. And the private subnet has a route for the net gateway that sits in the public subnet.
Oh, I'm triggered. That's going to bother me. So I think I wonder if one is for public and one for private cider block. For public subnetting. It might be. That's going to trigger me.
Which one? the secondary.
Secondary cider block. Is it for a private subnet?
Oh, maybe that's what it's for.
Yeah, that's going to trigger me. If I don't figure that out, that's going to trigger me.
If they're, yeah, like why would you want to have two subnets now that, yeah, so maybe one is public and one's private.
It would make sense.
Okay, it's just, yeah, I don't know the use case for it, but there's a way.
There's a way to do it. Okay.
Yeah. Okay. Cool. Nice.
Okay, so that's our homework. That'll be cool. So we have homework for next time. So we'll tell y'all if y'all come back next week. Maybe we'll figure this out. Cool.
Cool. Yeah. So we have our net gateways. And yeah, ENIs are created for it. And currently we don't actually support ACLs. We only support security groups. And security groups are based on what kind of node you are. Like, it depends on, it changes based on if you are a control plane node, regular node. For example, for control plane node, we have an additional inbound rule that allows traffic to 6443 API server port. This is changeable though, modifiable. This doesn't have to be 6443. And then we have our CNI Ingress Rules, and then SSH. We allow SSH also. This is our control plane security group.
Okay.
And if I go to the outbound rules, all traffic, as I mentioned, we don't support any customization right now in the egress rules. And
so there's no customization. So like if somebody wants to allow traffic out of the cluster or into the cluster, like from an egress perspective, what do they?
Oh, they can actually provide their own security groups.
Okay.
This is the default. So see here, I just added an example. Thought you would ask that. So
Cool.
they can bring their own security groups, which might have the ingress and egress rules.
Okay. Okay. So and that points to a, okay. Why does it say node there? What does that mean?
So node is for the security group that will be attached to the regular worker nodes, not the control plane nodes, because they have different.
Oh, okay. So security group overrides is a map, and there's different things.
Yes,
You
exactly.
can so what are the valid keys in that map? Nodes, control planes. Is there anything else? I guess that's it.
Yeah, load balancer, bastion. You can see here, right?
Okay.
Let me open description. Yeah, load balancer, node bastion, control plane. Pretty much it. Yeah. For the bastion, it's simple. Just allow 22. And the nodes difference from control plane. We don't need to open 6443. Instead, we only have the kubelet port. This is
So is everything in AWS in some kind of a security group, or is it only things that correspond to a network? I know this is a dumb AWS question, but like if I put an SSH key in AWS, that's not as in the security group, right? So what's the requirement for something to be a part of a security group? Is it just that it's a thing that's...
So a security group typically acts like a firewall, so that you can have a firewall in a sense, and have a firewall and control what ports can egress and ingress between on the network on your between availability zones.
Yeah, so I put a machine in a security group. That makes sense. But then it gets abstract to me once I start putting I can attach a security group to a lot of different API objects in AWS, right? Or is it only...
So it is true. It is true. Like you can attach a security group to things that are expected to do network type things like Lambda or your databases, or all that stuff happens on the wire. So a security key doesn't necessarily happen on the wire, right?
Are they maybe asking for policies instead of like security groups?
Well, policies are different. Yeah, they're a different thing.
Because security groups are.
So for your key, maybe the policy, Jay, may be more applicable. Who can get that policy? Who can open up those keys? Who can shadow those keys? The internal material to the keys.
Yeah, okay. I'm just trying to remember the whole data model for AWS. Okay, so Vivek has a question: are these rules auto-created or are they present in the YAML files?
They're auto-created if users don't provide them, but we support bring your own security groups also.
Yeah, which is, I think he asked that 5 minutes ago and I'm just now reading it. He asked the same question I think that I asked. Okay, cool.
Okay. Yeah, these security groups are pretty similar with CNI policies.
Yeah.
Actually, by default, all rules are denied. I mean, everything is denied. If you add allow rules, basically, it's pretty much similar with NetFalls.
Yeah.
And actually, all rules in the security group are applied. It is not like going one by one like ACS, knuckles. Like if you deny at some point a traffic, it gets denied. Although there's, for example, allow all rule above it, it doesn't matter the ordering. So. denies it all. So
Yeah. Okay, cool.
yeah, and yeah, let me show the load balancer as well. So we are still using a classic load balancer. The reason for that is
We're using
network
what load balancer? What load balancer?
Classic, deprecated.
Classic. Oh, okay. What's that?
So, yeah, the reason for that, we wanted to move to network load balancing, but there's an issue about hairpinning. So kubelets have a load balancer's DNS name, and when a kubelet wants to reach out the control plane using this load balancer, that load balancer may pick the same node that kubelet making the request, and that means it goes basically. Let me draw.
I mean, classic sounds bad. Like this is the wrong way to do it. And then there's a new thing that's not as bad.
Yeah. So somebody,
yeah.
while she draws, some of the evolution is that everything in the back in the day was classic, and then more recently, with I think 2018 or 17, AWS kind of encouraged everyone to do both do either an application layer 7 load balancer or a layer 4 load balancer, for to meet your needs. And so that they would strongly encourage you to do one or the other. Most people just use ALB versus ELB, and so but the classic load balancer has a mixture of the two. It does some of the application layer stuff and some of the lower traditional stuff in layer 4. So a lot of
so like you can make a classic load balancer and it'll just give you like an external IP, but then you can like connect it to a DNS thing and then it'll do that for you
at the same time. Yeah.
Oh, so it's like the Ingress rules in Kubernetes. Like they do all this stuff and you can kind of do anything with them, but not properly. And then they move to the gateway API, and which now nobody really knows how to make an Ingress rule anymore because you can do anything. So is the new load balancer hard to use? Like it's confusing?
Go ahead, you got it.
Go ahead. Yeah, the issue about CAPA is this one. Like kubelet makes a request to reach out the API server, and it hits the API server load balancer, and the load balancer directs the traffic to the API server that sits on the same node. This is a case that doesn't work with network load balancing.
Oh, you can't do that in Amazon? So if I'm a node, I can't use a load balancer to access myself? Wow.
Yes, it is big. As far as I read, there's a way to do it, but there's no way to do it in the API itself.
There's no idiomatic way to do it. You'd have to like forward it to some other VM that had a custom forwarding rule that forwarded you back to it or something. Okay.
Yeah.
Got it. Yeah. Cool. Wow, I didn't know that. Did you get that, Lubron? There's no hairpin.
Yeah, actually, we want to support NLB soon. Maybe there are new ways that we can use. We need to figure that out.
Well, the good thing is AWS is so big until they have to be slow about how they depreciate any of their services. So that's what allows us to get away with using classic load balancer for a long time.
Okay. All right, cool.
Yeah, so I forgot to mention, before we start bringing up a Kubernetes cluster with CAPA, we need to have some IAM roles. And we have a CLI tool called Cluster AWS ADM, which creates it for us. And let me quickly show you what kind of IAMs we are using. Yeah, so this is our CloudFormation stack. If we check out the resources, yeah, we are creating IAM roles for the control planes, Kubernetes control planes, CAPA controllers, EKS has its own IAM roles because they need to reach out to different kind of resources. And then we have worker node roles. We attach these roles to instances, and they become they can be used as instance profile. So when we check our EC2 instances, so I'm actually in the Antrea live cluster is in Ireland.
Oh, that's cool. Why'd you do that? Because the other one, because the AWS had an outage yesterday or whatever. So you moved all your stuff to Europe?
Not really. The other ones has some resources already. I just wanted to have a clean region.
I remember in 2012 there was a thunderstorm in Ireland, and I worked at a company that used AWS, and we had an outage there.
Oh.
So don't think you're safe. Okay, so now you've got.
Yeah.
Okay.
So for example, this IAM role is attached to the control plane node, which has all the permissions needed for the. So we attach this IAM role several policies, and for example, specific to our CAPA controllers, these are the permissions that we are using. It's quite a bit.
Okay, so you have an IAM, and then this is made by CAPA for us.
Yeah, and we are just. So this is the code. I don't know if you can see it.
Okay, so that cluster AWM. Wait, so do you still use cluster AWS ADM for everything? I remember that was a big deal when this Tanzu first came out. We had to use it. I don't remember how we used to use it, but we used to use it a lot when we were testing stuff. Is that still the normal thing? You use that, and then you use Cluster Cuddle. Those are the two tools you use.
Actually, we have now libraries in cluster AWS ADM package, so that external controllers just use those libraries instead of having to call a binary.
Okay.
So it got better.
Okay, so it bootstraps. So I create a kind cluster, and then the kind cluster can run the cluster API management cluster, and then that thing vendors in that AWS ADM and calls stuff to create stuff for me. And you just use it to debug things when you're developing. Okay, cool.
Yeah, this is pretty much it. So I have a couple of things to mention about what's coming in the near future, but
we've got 10 minutes. We've got 10 minutes. So can you walk us through some issues and PRs and stuff that people are hacking on? Or whatever you think else is coming up in the future?
Yeah, sure. So
cool.
Let me. Okay, so the biggest missing piece right now is that we don't have any flexible way to support everyone's networking topologies. We have a fixed topology. If you want CAPA to create all the networking resources for you, there's not much flexibility. If you want, for example, VPC-peering between your VPCs, you want different kind of topologies. The only thing you can do is bring your own VPC. Actually, we support that too. You set up your VPC, do the pairings, and everything, and then use that ID to create your clusters. But then you have to use tools like Terraform, Ansible to do that. One thing we can do to improve user experience is that to have a way to let users define their custom topologies. There are, for example, users are mostly interested in this kind of topologies where they have their VPCs. Say they want all their VPCs peer with each other. And for example, they have on-prem networking and They have a virtual gateway here. There's a probably a direct connect gateway. Please keep me honest, DWAYNE. I might
Cool.
forget direct connect
Yeah.
gateway,
Yeah. Okay.
where you have to like connect all your VPCs, and this is a direct connect link to your on-prem. Actually, we can make things very flexible and spin up all these resources for these kind of topologies.
So in this topology, like what's in this future that you're talking about here, what's the vision? Like the input is a list of VPCs and then the output is a cluster, or the input is a Terraform script? Like what do you think people should give?
Go ahead.
DWAYNE, you know what the customers are doing, right?
Yeah. So
tell us what they want.
They're going to use Transient Gateway, and if anything, CAPA hopefully evolves to using Transient Gateway APIs to just provision that hub and spoke philosophy between all their peers, including their on-prem connections. So Transient Gateway can handle all that. The trick with Transient Gateway is billing, like it always is, because you got to pay for throughput everywhere, and every network connection you're paying for throughput. Some companies I find don't mind it. Some it's like a hex, like, oh God, don't do that. So it depends on what you're loading, what you're pushing through the Transient Gateway.
Okay.
Yeah, and if you want to use VPC-peering, it is free. It is just adding some routes in the route tables of the VPCs. But one thing we need to keep in mind is that CIDRs should not be overlapping. And we don't have an IPAM right now in CAPA. That is something we need to solve before supporting all these kind of different network topologies. So in both Transient Gateway and VPC-peering technologies, VPCs should have distinct cidrblocks.
So Lubron is on my team over at VMware, and he's just sort of signed up to help with this CAPA stuff and working on the design for this. And I think he might be collaborating. I think Sedef and Nadir and a couple other people are helping him, bootstrap some of this stuff. So reach out to him on Slack. He says we're working at the design. It's only a draft. We'll share it when it's ready. So he's like, and he's working on a P0 right now. So he's got to get back to work. So yeah.
Oh, whoa, P0. Okay. If I'm not mistaken, I could have swore I read somewhere that they was able to do overlapping CIDRs with Transient Gateway. There's a way that you can do that, but I have to reach out to somebody who does networking like all the time.
Oh, okay, that would actually make our life a lot easier if there's a way, because actually AWS has this new IPAM news came out last week. Nadir shared with us. They have an IPAM support coming.
Oh, they do have a good. I was okay. Good. That might be what I was thinking of.
When you say they have IPAM, like what do you mean? Like, of course they have IPAM. Like what am I missing here? Like, it's not configurable
as a resource.
As a resource, okay, as an API resource that you can modify.
Right.
So they've never had that before? You could never have custom logic for how nodes were allocated IP addresses? It was all just monotonically increasing IPs?
I guess people were using their own IPAMs.
So they'd set up their own DHCP servers inside of AWS and
yeah, this is pretty much it. So we are gonna focus on we are thinking about having different networking resources separate from the AWS cluster resource, so that we will have networking reconcilers that will do all these cool networking topologies possible.
I do have a question. I noticed that there's some other open source like tools like OpenShift and stuff like that. They're they're now like saying that they can swap out CNIs, right? They can swap out CNIs. They have this thing called Multus, where you can swap out and choose your CNI on the fly.
Yeah, we did a show on Multus, but we didn't go super deep into it. But we did a little bit of a TGIK episode. We should do a show on that next time. But yeah, go on with your question, DWAYNE.
Yeah, my question is, does CAPA intend on offering the ability to swap out CNIs from Calico to Antrea to
you can use you can use either. So we definitely CAPA can support really any CNI. We know that it supports Calico and AWS.
Actually, Multus, if I remember correctly, Multus also supports using different CNIs in the same node itself for different ENIs,
and that's
network interfaces.
That's what I'm asking. Or can we swap them out? Or can we dynamically go from Calico to WeaveNet on the same cluster?
Yeah, if you ran Multus on your AWS cluster, why would it not work, right? Because all it does is when the pod comes up, all that Multus really does is you annotate your pod of what CNI you want, and then the pod makes a call to that CNI binary, right? Yeah. So as long as you annotate your pod with the right thing, I don't see any reason. I mean, I've never ran Multus on AWS, but we've run different CNIs on CAPA and they work fine as long as you support them with the CNI Ingress Rules, right? As long as you configure the network so that it allows the CNI to go and do its overlay the right way, right?
Right.
And at that point, it's the same functionality, right? Just containerd making a call to the CNI binary to say, give me an IP address. So as long as that overlay is working, but we should try it. I don't know. You never know until you try it. Maybe Multus.
And I thought that stuff was bound to the cluster when it stood up. Like, I dare you to swap me out.
I've swapped it out. No, I've swapped it out just trying to see if things work. That's the only reason I know. In the early versions of Tanzu, the way it used to work was it was really easy to swap the CNI because we hadn't baked a lot of CNI logic into it, and we only supported Calico. And so the first tests we did for Tanzu on Antrea was spin up a Calico cluster, kubectl delete the Calico CNI, and then kubectl create the Antrea CNI, and it mostly worked, except that we needed to open up some firewall rules.
Okay.
Right, that's the thing, and then that was the tricky part, is that you have to model the firewall rules properly. That's the only thing I've ever encountered, at least on AWS. Now the real interesting question is I don't know how we would do this, but should we start supporting AWS's native CNI? Like, because Antrea has I don't know if any of the Antrea folks are still here, but I'm wondering, Antrea has EKS native CNI integration, right? Where you can use just Antrea for network policy, but you can use AWS's native CNI so that you have native VPC IP addresses for your pods and you don't have that overlay thing going on. I mean, Antrea and Calico, I think Antrea and Calico both support that. I mean, obviously, I know Calico does, and I know Antrea does some level of that with Google integration because we looked at that last week. But maybe we can explore that next time. Whether you could spin up a CAPA cluster, delete the existing CNI, and then install the AWS native CNI somehow, and then only use Antrea for network policies like the way you would in GKE.
Yeah, I think that'd be really interesting. Obviously, there are advantages to using AWS's things, right? Which is the reason why people use EKS, right? So, we want to be able to take advantage of that if that's made available to us, for sure.
Yeah. So, things are, So I don't know what you mean swapping the native CNI. So Scott's saying it's not easy at all.
That's what I'm saying. That's what I was curious. So I know what Multus you can, but I've never seen it done. But I was wondering if CAPA had interest in, hey, the next version of CAPA or coming down the road, you're going to be able to swap that out, per cluster. You can have one cluster running one thing and then tell CAPA, hey, I want to change the CNI over in that guest cluster number 5 right now.
I mean, I'm kind of wondering, Scott, what do you mean it's hard? Because I've done it before. Like, I've deleted running CNI and then like, unless you're talking the AWS native one, like if you're running just an overlay CNI, like that's not, in my experience, hard to do at all because you can literally just delete and recreate the CNI. But like, I'm not
running a workload, Jay.
Well, Core DNS, right? I mean, that thing comes up on pod IPs.
Yes, it does.
Oh, he's saying VPC CNI. Okay, so when you say VPC CNI, you're talking about the AWS native one. Yeah. I've never tried to use it, right? So I don't know how the AWS native one works. Yeah. Yeah, I got what you're saying. Yeah. We're in violent agreement, me and Scott. We're agreeing that like just a Kubes, you can easily swap a CNI if it's not natively integrated with Amazon. Yeah. That's the easy thing. And then the hard thing is hard, which is like, and that makes sense, right? Because you would, if you were to set up the VPC CNI, then it probably has, it's not using the host IPAM. Probably it has its own IP. Who knows what it's doing? I don't know. Maybe it has a VPC native IPAM and that uses some other IPAM. And so if you were to delete that, all your pods would come up with totally different IPs and different IP ranges. And I don't know.
Hey, Jay, in your experience,
we're doing a pod experiment.
Yeah, I know we're about to drop. In your experience, I never really understood the opinions around Antrea, other than branding, versus Calico.
So, Antrea, me and Sedef gave a KubeCon talk about.
You
can tell DWAYNE about the KubeCon talk we did about this.
Just send me a link.
You came to the right place.
Send me a link. Just send me a link. I'm sorry. You can just send me a link. I'll catch up.
They're just it's just an alternative, and it uses OVS. It's got native integration with different things than Calico does. But I think I would like to say that Calico and Antrea have both made each other better. Like, we work openly with the Calico community. We coordinated some stuff around Containerd on Windows. Like, as we got it working, they got it working. Kind of, we shared some ideas. So we use Open vSwitch, they use BGP, or they do the cloud native stuff, and then Antrea does the cloud native stuff too. And so they're very similar, right? Like, but Antrea uses Open vSwitch as the data plane instead of the whole BGP thing. But they, and they both have an overlay option, right? And so there aren't strong, like for an end user, there aren't strong opinions that really differentiate them. I mean, we don't have BGP. Calico has some level of BGP integration for services. We have Antrea proxy. They also have the BGP service proxy thing. So like, they're able to swap out the kube proxy for their own native routing solution. And so is Antrea. So there's more similarities than differences for sure, right? And we both pass conformance. We both pass all the network policy tests. We both pass all the hundreds of tests that are inside of Kubernetes, and we're all contributing to those together. So I'd say we have more in common than different. But if Junjin was here, he might disagree with me. I don't know. Okay, cool. So that's it. It's 5:04. We try to keep this into an hour. Sedef, DWAYNE, thanks. DWAYNE, and come back and do a show with us sometime. And Sedef, come back and do another one. This is really cool. I haven't looked at AWS networking in like 6 or 7 months. So this is really good refresher for me. And now I remember how CAPA works. Yeah.
Awesome.
Cool.
See you around.
All right. Thanks, everybody. Antrea Live. See you later.